Okay, so let's move on to operational concepts. The key concept here is the minimal clinically important difference, or the MCID. This was first mentioned in 1989, and the concept here, or the reason that this came about, is in the era where statistics and inferential statistical tests, particularly Fisherian statistical tests, have become or are the most prominent way of determining significance. This concept is trying to bring back significance to what is actually important to a patient or a person. So physiologic measurements may change without people feeling better, or a drug may ameliorate symptoms without measurable changes in physiologic function. So we can denote changes, and perhaps this can give us a p-value less than 0.05, but does that actually mean that people are feeling better? So trying to establish meaningful differences, not just statistically significant differences. Now, to arrive at a minimal clinically important difference, there are several methods that can be used, and we're going to go over each of these in turn. These methods generally are all deployed, hopefully they form all the different inputs that an expert consensus can filter out and arrive at a MCID, at agreement. So let's talk about distribution-based methods. So this is just one aspect of trying to arrive at a meaningful and a valid MCID. But this uses only statistical measures of spread, of continuous variables, or frequency distribution of observed events to determine significant difference. So this is sort of the statistical component of arriving at an MCID. And these distributions that we speak of, they can be the baseline measure in a population. For example, you could consider the average serum cholesterols in a baseline population. You could look at one standard deviation, and you could define anything outside of that standard deviation as a significant difference. Again, this is just one aspect of MCID, but this is the baseline. You could also look at effect size in a population. So instead of this measuring the baseline serum cholesterols, this could be measuring the difference, the pre and post difference in serum cholesterols after treatment with a known drug that improves cholesterol, lipid lowering drugs. So you could look at the differences or the effect size, and again plot a distribution and look at the standard deviation of that. And then you could also look at the distribution of an instrument of measure, which is more or less testing the precision. So for example, you could take my serum cholesterol and measure it 1,000 times roughly around the same time of day, and you could see sort of my average variation, and you could use those also to help distinguish what is statistically important or reasonable or normal variation, and what is sort of outside of that variation according to the instrument's precision. Some often used examples are standards as a half a standard deviation or one standard error of measurement, both of which I will not go into detail. I know other courses discuss this. Again, this distribution-based methods helps you determine what could potentially be statistically significant at a specific p-value with a sample size. But as when we started talking about the MCIDs, statistical difference does not necessarily mean clinically important. So that's where the other balancing method for determining MCID comes into play, and those are the anchor-based methods. This operationalized a theoretical concept we just spoke about, which was criterion validity, and essentially it restates that. So this compares and evaluates measures from one scale or instrument to other measures of impaired health. So it anchors one scale in one or more other scales. So one way to conceptualize that, we talked about SAT scores. So let's say we're trying to determine whether the SAT threshold of, let's say, a score greater than 1200 is important. Well, we could anchor this SAT score and the performance on the SAT score to other important measures using concurrent measures that are also considered important. So high school GPA, that's one we could anchor this in. Sorry, this looks like I'm writing with my fist here, but it's a mouse. We could use it with a predictive criterion validity, or college GPA. So how does it correlate? How does either a threshold such as above 1200, or you could be anchoring a change, so every 100-point difference in SAT is correlated with a difference in high school GPA or college GPA. If we wanted to go out, if we wanted to anchor it in other important domains, we could look at salary in the future. Is it correlated with salary in the future? So these are just some examples of how you can use other measures to anchor the measure you're interested in, and you're anchoring it either at a threshold or at a delta, important difference, like I put 100 here. The numbers here I'm just sort of pulling off my head. These aren't meant to be completely real life examples. So these two methods are hopefully, in an ideal world, formulate the inputs to an expert consensus. One method of expert consensus that's known is called the Delphi method, and there are many variations of this, but essentially a panel of experts is assembled. Each expert is provided these inputs, anchor-based or distribution-based methods, to review, and each individually and independently, without discussion with the others, develops what their understanding of they think the MCID should be for whatever measure is in question. Somebody collects all of those inputs of all the experts' independent inputs, and then they're averaged, and then that average is sent back to experts with a request to revise their original score, and this can be repeatedly done until some general MCID is agreed upon, or a range. So this is an ideal situation. Often we don't have all these different anchors available to us. So if we don't have an MCID available when we're developing our study, sometimes it's just up to us to make some poignant arguments of distribution of the measure that we're interested in, maybe some anchoring, and that anchoring could be as simple as what other studies have published. Hopefully it's anchored in some other domains, such as predictive of other outcomes, predictive of other important measures of disability or hardship or quality of life, something to help validate why this is a clinically important measure that we're looking at, and what difference we're looking for, that's an important difference. I left this here as a note for myself to remind myself and everybody that MCID doesn't always apply in purely exploratory research. Of course, this isn't really looking at differences. Purely mechanistic research which again is fairly exploratory. Sometimes the MCID is the subject of research, so your research can be engaged in looking at different scales, correlating them in order to establish some important differences, and what the important differences are. Excuse me. Okay, so we've really just covered validity. Next, we're going to talk about causal structures, just one component that can be used to describe your endpoints and outcomes.